Hello everyone, and welcome to this second installment on the construction of the Folger FT-6 3D printer. This will cover the electrical assembly of this printer. I wanted to preface this video with a bit of a discussion about my design philosophy. I take electrical safety very seriously. So throughout this video, you're going to hear me comment and occasionally be relatively harsh when I find things that I consider unsafe, as well as just from a general standpoint of circuit design and layout and arrangement. There may be plenty of right ways to do things, but there are also plenty of wrong ways. And so there's definitely a right and a wrong way, and if I see something that I think is the wrong way, I'm going to point that out as well. So I'm not pulling any punches in this video in the discussion. And of course, on top of that is the aggravation of essentially no support from the manufacturer, no completed documentation, missing parts, and considerable other issues that you'll see discussed. The big thing that I will say is that from a safety standpoint, I do not believe that this printer would pass typical electrical safety requirements, industry safety requirements. And so if that's a concern, then maybe you just want to stop here. Certainly, I would not use this around children. And I've taken steps as I've built my design to address some of the issues that I've seen. But again, this is something that you should be aware of. Folger has a number of disclaimers on their website about the safety issues and that sort of thing, but frankly, as I've indicated to them as well, that doesn't matter if the design itself is flawed. Then that's not a safety issue that is the user error, that's a safety issue in the actual design, and that's their responsibility. So like I say, throughout this video you'll see some of that information, but rather than stun you with it as we went along, I thought I would mention that up front. Through a process of elimination, I have managed to put the electrical components that go inside the box in place. Basically, I just had to match up hole sizes and figure out where things logically would go. Of course, this board, to figure out the way it's supposed to be oriented, you have to look at the top component here. And so this top, if you look at the picture, these holes are supposed to be towards the front. And basically what that means is that this interfaces like that. Right, so you notice how you've got the two tabs at the back, two tabs, and then a gap. So that means that's the back side. And of course, as you start putting components on, that becomes logical because basically you have your IEC power inlet that has the switch, the fuse, and the AC power connection. That will be on the back panel. And that will feed directly into the DC power supply and into this solid-state relay that drives the hotbed. So since you have a 110-volt heated bed, this drives that. And then this is low-voltage DC that will come from the controller board. The controller board, logically, is at the front of the unit. It was somewhat arbitrary as to which way to place it, but it made more sense to have these connections at the back. Then you have this one little routing board. Now, you'll notice there's these set of small spacers, and so those are the standoffs for the PCB. So these are all M3 screws holding the PCB. You'll notice that there's actually a hole pattern apparently for a larger board, as well as for the one we have. And similarly with the power supply, it looks like there's an extra hole here for a longer power supply. Now, I went ahead and I had to pull the back panel off of this for a couple of reasons. First off, it's actually not possible to get this sideboard into its slots with this board in place. Now, a couple of other things that, you know, this is basically right below the AC. The wiring here, they've got some shrink wrap on it, but of course it's still exposed here. The black and white color code is okay for something that's distributed to the US, but this is not standard international wiring code. This should be, the black should actually be brown, and the neutral should be blue. And then there's also the question of, is this ground or chassis ground? And that should actually probably be green and yellow. I need to double check. Yeah, it looks like that goes straight. So you're actually, your safety ground is in the filter, but none of these components are electrically connected. So from a standard safety requirements, we've already got problems in terms of this being a safe electrical housing. Plus, this will also not pass the directive because, you know, there's no fan for this hole. This is just a vent hole. And, you know, I can stick my finger quite a ways into it. Kids could stick their fingers into it. Kids with screwdrivers or other implements could stick it in and actually hit the electrical contacts. So this is not, this would completely fail the safety directive for electrical. And of course, the other part, you can see this actually has a hole pattern for a fan. So it's got a big opening, and then it's got a hole pattern, but of course they did not provide a fan. So again, now I can stick my biggest finger through it all the way in to the point where I could potentially touch some of this electrical. And then even on the top, now this vent is intended to be near where your driver is, so it's not by the power supply. But again, if you read the electrical directives for designing enclosures, you're not supposed to be putting vents over electronics because of spill possibilities, or at least not this type of vent. So the reality is to ventilate this needs to all be much smaller holes on a finer perforation. It's cool that they were going to put their kind of logo pattern here with these hexagons, but from a safety standpoint, this would not be considered safe. It would certainly not pass anything like UL or anybody else. So just be aware, you are taking this into your own hands. And I would say the same is probably true of this cable that's going to be, of course, moving up and down and, you know, have 110 volts on it to run the heater. The question there is, you know, abrasion and things like that, that really ought to have probably some additional sleeving on it, as should all of the electrical components, even the low voltage DC. And like I say, we're already starting off kind of on a bad foot here as far as electrical and safety. Now, the only thing that we have to date for how to assemble this is a single PNG file that gives you essentially a schematic wiring diagram. So it tells you what the connections are supposed to be, but doesn't tell you anything about cable links or how to route them, where to route them, etc. It does actually tell me one thing that I'm kind of surprised, is that those two X motors are actually not driven independently. They're just wired in parallel with this little circuit board. So you're putting twice the load on that particular driver chip, and Presumably it works, but I don't know for how long or how well. Like I say, so you've got the solid state relay there that's driving the bed, the power supply, the AC inlet. This is this circuit board here, is that one there. That's the distribution board up on top. And so it's enough information, as long as all the wires are here, it's enough information to figure out how to wire it. But again, we're kind of on our own. The other thing I'm not seeing in any of this is really any sort of cable handling or anything like that. Right? We have some USB extensions and other parts. It actually took me a while to figure out what this part is. This actually goes behind the display, so this is the front cover of the box. And so you've got a mount for a USB, but then you've got this big opening that's just where the wires that go to the display go. So now what we have that will be in front for mine, I'm going to have this set up with the large display. But you also have, whoops, I believe it goes this way, would make more sense. You have this for the small display, which of course I won't be using. Alright, so digging through the wiring package a little, what we find are two relatively long, close to 1 meter long stepper motor cables. All of these cables have a different connector on each end. So you can see how this has what appears to be a 6-pin connector versus the other side is just a 4-pin connector. And so you will have to make sure that you route them the appropriate way. So we've got the long cable, we've got one medium length cable, and then we've got 3 short jumper cables. So we know that one of those goes to the Y-axis motor. We know that 2 need to go to these motors. Now what I don't know is, okay, what's the intention? Is it take the long pair and run to this, or is the long pair for that, or do I even have the drive for both of these? So, you know, this wiring diagram, first off, does not actually show anything about the filament drive. So that's obviously those last 2 connections. I'm hoping there are cables to actually drive them. We'll see that shortly. A few more cables. This looks like some relatively large gauge wire. I'm not 100% sure. I'm assuming that's some of the internal wiring. Another little blob of wire. I'll have to take a closer look. You've got your 2 Ethernet cables, essentially. Although they aren't really Ethernet, they're basically using a that connector, but they're relatively thin. And then there's just a couple more short jumpers in the hole. Here we have that one small jumper board that's shown in the picture, as well as a couple of additional wiring components and some sticky tape. So for mounting on this front panel, you can see the location there, which looks inset to actually have something fit, but it's really just going to have this behind it. So you have this USB-A to USB-B jumper that goes to your control board. And then you have basically a maybe a 1.5 meter USB-A to A cable. So the cable's barely long enough to get from one end of the printer to the other, much less get down to a computer, unless it is right by the control side, which of course in my case it will not be. So I get to turn around and go buy another cable. You know, put a decent cable in this, especially if you're using a non-standard connection. Let's get one that's at least 3 meters long as a standard on this. Now, in the electronics package that had the main board in it, there's also 5 little heat sinks, presumably, which are supposed to go on to the 5 drives here. Again, no direction or otherwise, but that's the logical place to put them. Then we have 3 of these little end stop, which are basically a switch that I can't even hear click, so I'm not sure about that, but it doesn't really matter because it looks like we throw these away. And the only thing we're using is this excessively long cable to jumper from here over to this board. So you see that right there. Then apparently, so we've got the Y and the X end stops here on the gray cable. My guess is that the intention here is that the leveler is supposed to be your end stop. Alright, so I was talking about the end stops prior to my battery going low. As you can see, the X and Y end stop come through this gray RJ45 cable back to this jumper, and basically you're just jumpering that over to the main board in place of the limits. You'll notice this board is actually color-coded, so you have the reds for X, the blues for Y, and the greens for Z. So you have potentially an upper and a lower limit here. We're only using one side. The last one, the Z stop, there is no Z switch, but if we look very closely in here, that connection is labeled 5-volt auto level. So apparently our end stop is the auto level sensor, so we better hope that that's working well. The other thing, of course, this again is just part of the whole cable management thing. These things are just loose cables and a complete mess. Now what I'm doing here, and it's not ideal because this isn't the way I would normally do it, is I'm going ahead and twisting these, and I'll do that to this last one. Then I'll also just bundle them up here with some tie wraps and stick pads, which of course are not included. So I don't know if the intention was just flop cables around, mix your high voltage and low voltage or what, but again, not much thought given to this. The way I would normally make this sort of cable, and if I had enough of the connectors or the crimp pins to redo it, I might go through that trouble. But normally I would just sit and, take a long set of wire, and what you do is you tie one end off to whatever, and put the other end in a drill. And you just run that drill and you twist your wires up, and I'll actually grab a sample. I should have gotten one of some that I've done that way. And you'll see first off that it does much nicer. The problem doing it by hand, among the fact that it's a pain in the wrist at a minimum, is the fact that the ends of the wires, they're already captured. So they can't actually twist around and relieve some of this stress that's being put on them to actually unwind, if you will, in the opposite direction. So that's why this is not bundling together very well. I'll show you some that are done the right way, just to give you an idea. So for comparison, here are a couple of leads out of my scrap bin. And of course, depending on how far you go, you know, I mean, this is a nice tight wind. I mean, it's beautiful. The challenge, of course, as you go to something this tight is you actually are shortening your cable quite a bit because you're spending a lot of it twisting. But you see how these, I mean, they twist, you know, here's a 3-lead smaller gauge, but, you know, they actually hold nice and tight. But again, the connector's put on after the twisting, not before. So anyway, would have been nice to have cables designed like that as opposed to this wire spaghetti that we've got to work with. Also be nice if they were actually designed just to reach where they needed to go. But we'll try to clean this up and let you see what it looks like. Alright, so I took one more pass at twisting these, which, again, since they can't relieve the twist in each wire, that's making them want to double up and twist, but frankly, that's fine since I'm trying to take up a bunch of this space anyway. But now you can kind of trace, okay, we've got switch 1 going to endpoint X. We've got endpoint Y then, this one here going to the middle, and then we've got green going to our endpoint Z, which is the 5-volt auto level. So, a lot of trouble just for those 3 wires, but now I'll clean them up and get them out of the way. Alright, so here I've cleaned up the cabling a little bit and tie wrapped everything bundled together and used one of the little sticky pads. It's basically one of these things. If you're not familiar with these typically are sold right where you'll find tie wrap sold. And for the most part, there's something from a hobbyist standpoint you always want to have around because that and tie wraps are very useful. Now, at the same time, I will say as a design engineer, the use of these, especially the rampant use of these and tie wraps, etc., generally indicate poor planning and design. You didn't actually design your wiring in, you just decided to let whoever's doing the assembly just slap stuff on and do whatever they do themselves. This particular setup begs for the use of something like P-clips because with the extrusion and the T-nut approach, you could very easily take P-clips and just screw them right into the rail system and have your wires very nicely handled versus having a bunch of ugly looking tie wraps. And I may go grab some P-clips, I've got some somewhere, but the other thing I was going to show is I did go ahead and put those 5 heat sinks on the 5 drivers. Notice that all the fins are vertical. Since this is just being passively cooled, it actually makes a difference which direction those fins go. So having them vertical will allow convection to carry that heat up through them, where if you had them horizontal, they'll actually be somewhat less efficient. So just another little tidbit to be aware of. So next we need 2 sets of jumpers from this left side of the board, one of which is the thermistor for the hot end, which is going again to this board here that distributes that through the RJ45s. The other of which is actually long and is highlighted in red that actually drives, okay, those are the ones that are coming off the bed. So the second is the red thermistor lines coming off of the bed. What you see, though, is that actually requires that connector on the end. And here is what's on the end of the bed, just bare wires. And no one, I actually have crimp tools, but your average person is not going to have the proper tools or even the connectors to put that on. Apparently, what they intend for you to do is, in the bundle, there's this one long cable that, lo and behold, has what appears to be a thermistor on the end of it and has the correct connector. My guess is that they've actually bought a number of these things as kit components from some other vendor. So they're probably getting the board and a set of parts that are intended for other applications. I guess the intention is just that you're supposed to chop these off, and then, I could solder and heat shrink these, but the average person would probably just tape and tie and tape. So, again, not well planned. Why they didn't bother putting connectors on the end of this, I have no idea. And of course there's nothing else included. The only other connector is this short one that I've already twisted up that will make that jumper that actually goes to the upper thermistor. On the other hand, I did just come up with a brilliant solution that avoids me having to chop up this thermistor cable. I talked in the original assembly video about the fact that the power supply, or sorry, the fan for the hot end has a normal fan connector on the end of it that doesn't have any place to plug in. You've actually got to cut the cable and attach it. So we're going to be cutting this end off, and lo and behold, it's the exact same connector. So looks like we have a solution without destroying that cable. It still means jumpering wires. If I've got some crimp pins or want to fool with trying to carefully remove those crimp pins, I could potentially crimp them directly on the end of these wires, but we will have to see. So I went ahead and untwisted the cable with the thermistor and AC power for the bed. And again, we're faced with this individual strand approach that's being used on this stuff. I don't understand why they aren't using or providing some sort of cable handling mechanism. You see this is the normal split type. Either that or the spiral here that are used in this. That's the type of thing that I would expect to see to manage these wires that are just going to be hanging out here. I mean, these are AC wires. Leaving that open like that, now we have an inductive loop. So if I have that and I'm putting current through it, I'm actually inducing current into other things. That causes heating. That's again, it's complete violation of electrical code at a minimum. So tomorrow, that's going to be one of the things I'm doing, is looking for some cable management materials. I'm also a little concerned just about the potential coupling between the AC signal that's going to be driving this thing and the thermistor that's supposed to be monitoring it. Normally for most stuff we're using a DC cable, and you don't, or DC heater, and you don't see that sort of problem. So here we've got a different issue. In terms of routing, obviously this will be better once I get some of the rest of all the short connections done. I will mount this in its normal position, but that's obviously where this needs to come through. These particular cables you don't want to route underneath and back. this is another case where there really should be a grommet to go in this hole. Ideally, it would be a round hole, and you'd pop a grommet in there and protect the wires from this metal edge. So that's something else I'm going to have to look for, is a good way to protect this. Don't really want to just go put a bunch of electrical tape on things, but that might be what I have to do if I can't come up with something better. So before I route anything through all of these slots of nice serrated metal, I'm going to come up with some solution to protect everything. One of the things I meant to mention at the start of this, which I have looked around and I can't see anything, I'm going to be quiet and we'll see if you can hear whatever is moving around inside this power supply. And whatever it is, it's not the screws at the end or anything else on here. But I'll be darned if I can find where it's at or what it is. I've certainly looked in and under it quite a bit, but without ripping it open. I just hope it's not a blob of solder or a loose screw that's going to cause this thing to blow up on me. So as you can see, we've routed the one thermistor line over to this board. It's relatively short, so it pretty much has to go straight across. And as far as these connectors, these are basically a rather standard type of spring-loaded connector, and you see you just slip the wire down in, stripping about a 1/4 inch off, and you push the terminal in, you push the wire in, and then you release and it should clamp, and you should be able to pull on it and confirm that it's actually tight, caught in there. You don't want to catch the insulation though, so that's one of the challenges here. It looks like it's designed where it could cut through the insulation, but in this case, I don't believe that's the case. So next, I'm routing the main DC power supply lines. There's this heavy gauge wire that's supplied that is suitable for the high current application for this 24 volt supply. And if you look at the end of the supply, you can see on the left hand side you've got line, neutral, and ground, and then you've got 2 minus terminals and 2 positive terminals. So I've already attached the positive. You want to strip about a 1/4 inch worth of wire in there, and then you've got this little pop-up lever. You can see here on the end how it's got a little catch that will snap closed. So that's a pseudo safety feature. It keeps your fingers from getting in there too easily, but it's not a complete isolation. So you'll see as I loosen this up, there's a little tab that comes up. You want to stick the wire underneath that tab, and let's see if I can do this while I've got the phone here. Looks like I'm going to have to loosen it a little more and probably twist this wire a little more. Of course, depending on the type of connector they have, that screw may come all the way out, so you want to be careful not to completely remove it. So you want to insert it, making sure that you don't get any loose strands flaring out. Now if I can get into the slot, we can clamp that on down. It's very challenging to do left-handed. Alright, now I'm going to twist these up. They're not going to stay twisted because they've got a lot of rubber insulation on them. One warning, make sure that you look at the power supply. You might not get the exact same power supply that I've got, so the labeling could be different, the connections could be different, so make sure you double check that. Basically now we're coming over and you can see these say 12 or 24 volt, positive on the bottom, negative on the top. Should be able to use either one of these. Basically looking at the print that they provide, the plan here is you've got power coming in from the power supply. They're using the top one. I think it's somewhat arbitrary. And then they take the bottom one and they come over and feed it into that upper stage using this upper connector there. I'm not sure at this point whether this big heavy cable will actually be able to feed into that connector. We'll take a look and see. Now, the 1/4 inch that I trimmed here, you only need maybe just a little more than 1/8 of an inch for these Phoenix connectors. So you don't want to strip quite as much off, or you'll just have exposed wire hanging out, which you don't want to have. So let me twist this up and strip the other end, and I'll show you that. So you can actually do about a 1/4 inch of wire on these Phoenix connectors. You have to actually unscrew the connector before you put this in. So let's see if I can get at an angle here. So you can see how these are actually closed, and if I unscrew, you see how that opens up. Now you've got an opening you can insert the wire into and clamp it back down. So that's how those connectors work. Alright, so that has our main power attached. One other connection I can make just on the board is using one of the short motor drive jumpers. The documentation shows that going to the X, but it's the gantry Y motor, which, if you look at the board, that's the Y connector, that's the X connector. So I don't know if Folger Tech intends to do something non-standard or if this is just misdrawn. Again, since they aren't being very responsive, I won't be able to find that out for a while. The other thing you see here is the 18 gauge black hot end heater. That is this wad of cable. Again, I'll see about twisting that into something a little more usable along with the Ethernet cable that has to go up there. Alright, so judging from what we have for the rest of the motors, we've got that little jumper board shown here for the dual X motor. Now, to me, the logical thing would be for that jumper to actually be up on this platform here between these two, so that you had one short cable and then you ran the long cable down and into the electronics box. But judging from the cable combinations I have, because the last cable, of course, is going to go to the Z-axis motor, that's going to be that one medium length cable that we had. And then we've got the two long cables that will go up each post apparently. So basically this goes in here somewhere. Of course, you see that there are two screw holes, but there's no matching hole pattern in here, as well as there are no spacers for it. We could potentially attach it to this one spare hole or hang it off of one of these along with the existing PCB. The reality is it came in this package with this little chunk of double stick tape, and along with these two connectors, which appear to be for some of the high voltage jumpering that you need here. So if we look at this, remember the bed, the one lead that's shown here in black coming from the solid state relay to the bed, that can actually be one of these direct white leads that we've got. But the other, where we've got to connect from the neutral on the IEC inlet, that has to be jumpered. So that's what that is for. The other high voltage connections will all go straight into the power supply. So they've already made jumpered connectors on the IEC inlet itself. Those two will go straight there, but we've got a jumper between the bed lead and the other connector there. Part of the issue, I'm kind of limiting what else I do, because I'm getting to the point where I need to start routing things through sharp holes. So I want to get some cable management equipment tomorrow. So this is probably where I'm going to call this quits. So I decided to see about routing the cables for the x-axis, and was thinking of different ways to deal with handling the column, and was wishing I had something that I know they make for this, which is an insert designed specifically for cable management when you've got an open run like this, where you just pop it in and the cable goes behind it and it holds in. And while I didn't have any of that material, obviously, and it's not provided, what I did have is some old Cat 3 flat Ethernet cable. Basically, pretty much junk cable. I'm using pieces of it for other things, but I basically just split a strip of it in two, so I now have two pieces that I can use for doing an insert like this. And when I push that in, it basically completely hides the cable behind it and brings it all the way down. I mean, this is now inside the box that we'll be building here. So I can do that on both of these inner sides, and it will keep the cable in there and keep things from getting tangled up. Now, I still have to accomplish something, and right now the problem is I don't even know where the cabling is for this thing. So that's somewhat problematic itself. And of course there are other cables that have to go up that I don't think will fit that cleanly, because I've still got those two RJ45s that have to go, and I don't think I can get everything inside the column. But this is a pretty nice approach for this particular part. Alright, so I had to remove the corner panel for the electronics box off the back for a couple of reasons. First off, in order to get the board that actually holds all of the mounting components to fit, these tabs interface with that board, and you can't actually get it into the slots in the main panel without pulling this loose. So you're basically going to have to put the panel that goes across here in first, then put that back on. In addition, I needed to install the power inlet, and that could have been done from the back, but would have been a bit more challenging. This actually lets you see how that's done. In terms of the screws, this goes in from the back side. The hole pattern here, it actually had M4 size holes, but this is apparently designed to have countersunk screws in it, which we didn't have, and the holes didn't exactly line up either. So these are actually M312s with the couple of the last lock nuts that we have for those. Hopefully that's about all that we're going to need left after mounting all of the components on the panel, and that will let us continue. All right, so I believe I have all of the onboard wiring complete here. The only thing left is going to be the AC power inlet here that we'll have to get wired on this side, and then the connections to the hotbed and the 2 Ethernet and the remaining stepper motor drives, which the 2 extruder cables, as I may have mentioned, did not come with the kit. So I'm waiting on those. I may have to just order them off of Amazon, but I'm hoping that Folger Tech, I've reported the issue, and hopefully they'll ship those tomorrow so that I'll get them in the same amount of time I would get them from Amazon. Let's hope. Okay, let's talk a little bit about what I've wired up since the last round. So we have this set of wires here, which are basically just tapping off the 24-volt supply. Now, depending on the board you get, these 2 connectors may not be populated. If you look online, you'll see cases where they haven't populated that second connector. And actually, in some of the latest documentation, Folger Tech did just send me a Alpha 6. They'd actually published it yesterday, but didn't have any electrical in it. Then they updated it with some electrical, although it doesn't take me any further than I already am. But they actually show going ahead and using the extra 2 terminals here to tap that off under the assumption that you don't have that. So if you need the 24 volts, that may be the option. Now, the thing to realize, we're also going to have to, for the front panel display, we've got the down convert DC to DC power supply that runs that front panel. So I've got to tap that off of somewhere as well. I don't really like doing multiple wires into one connector like this, so that's what currently I'm planning on connecting to the extras over here. Now, actually, I'm sorry, I made a mistake about what the new drawing shows. So the existing drawing actually shows this. So if you look here, it's showing that jumper between the board and the main board there. So it's, even though the picture shows not having the connector, they're assuming you had it in this drawing. What Folger Tech showed tapping off of the 24-volt supply, actually, now that I'll have to pull up the sheet and show you here. That's what I have here, is in this step, they're showing actually connecting the fan. Well, that's your fan that goes up to your extruder fan. You don't want that on all the time. That's supposed to be being controlled from this fan control right here. So there's an output specifically for controlling the extruder fan, and so you'll see that's what I actually have that routed to. That was never shown in this original drawing. So, going back to what this connection is, this is the one that's actually not in the new drawing, and if we look at the board that's being shown here, you may be able to tell that's a different board. It's got a different connector in place of the one that I've got. And that's because in this case, that's for the single extruder direct drive, where I've got the Bowden and the leveling sensor. So essentially, you've got a choice of, you can't get the leveling sensor on the Bowden because you don't have the place to run the power to it. Or sorry, not on the Bowden, on the direct drive. So that's why the two are sold separately like that. You can do direct drive, but you don't have the leveling sensor, or you can do Bowden drive with the leveling sensor because you're running the steppers a different way. So that was a little bit of a shortcut, and basically what they've got is they've got the same board with two different hole patterns depending on what you're connecting. Now, I mentioned previously that you've actually got this thing up here at the top that goes over and is the Z-axis limit sensor. Well, you can understand that if we come in, and sorry, I know this is upside down, but maybe you can read the voltages there if you turn your head sideways. I might try to digitally flip this over for you. What you saw there, though, is that basically you have power, which is going to be the 24 volts, ground, and then an open collector drive. So they're taking the 24 volt supply here and feeding that up to that connection. And of course, I'm going to double check all of this with my meter to make sure that this is really doing what I think it does before I connect it, because, you know, if you apply 24 volts to the wrong thing, you'll be very unhappy. Let's see, I think that covers everything. This connector sitting here, that's going to go to that little jumper board, this guy. But I've decided I don't really want to attach that to this panel. I think I'm going to attach it to the base, so I'm just leaving that disconnected for now. The other thing you'll see here is, so I went to Home Depot and Harbor Freight today, and I bought myself a bunch of this sort of cable. So Home Depot sells a kit of 1/2 and 3/8. I'm going to probably end up using the 3/8 for most everything. And it's basically just this split cable handling. So you just slip the cables in it all the way down, cut it to whatever length you need it. And it's very useful stuff. Like I say, that's what is feeding the vertical axis on this for the hot end. So, you know, it's very flexible, but keeps all the cables together. So again, I'm not sure why we don't have it. The other thing I bought, now you'll notice it's a much smaller set there, but they had this kit of the spiral as well. The useful thing about the spiral is that you can take cable out of it or wires out of it wherever you want, and it still holds them in place. You can do the same thing with the split material, but you need a tie wrap or something just to keep it from slipping further out. Now, the other thing, I was actually looking at grommets, and there wasn't anything available that would do what I wanted for this thick panel. But what I can use is I can take a piece of that same material and just open it up, rotate it around the holes, and now I have a really nice insulating grommet that is going to prevent wires from abrading against that. I do have to worry a little bit in this case about the seam. If I cut this a little longer, potentially you could get those to overwrap, you know, completely cover each other. But that's kind of at the risk of closing up your hole because you put so much material into it. Now, the other part of this is that since this is going to be the heated bed, so it's going to be the bed heater and the sensor, essentially I'm going to run another piece of this material and I'm going to bring it all the way inside. Right, so going up that heated bed, all of those wires are going to be inside this. So it's going to be double insulated with this material in addition to the wire insulation itself. so it will be very well protected at that point. And so that's the plan on how I'm solving that. And like I say, when I do that wiring, they do have a good drawing added to the new system for that, as well as, I mean, the old drawing was fine too, but now they at least give you an idea of what they intended, if I can find the actual cable here, or actual drawing. Alright, so here's what's in the new manual, and as you can see, so we've got the control line, first off here, going back, and it's being driven by the bed heater drive. Now the one thing here that's kind of different, you know, that's driven by that big power transistor, because normally when you're running a DC bed, it draws a lot of current, and so you've got this big connector carrying, driven by that big transistor. All that's going to is basically just a logic input, right? So this is just a logic input that is driving the enable of the load. The one thing that would make me feel a little more comfortable in this design would be you don't want to be drawing a whole bunch of current out of there, right? You don't want to shorten this wire or something else causing problems. So a limiting resistor probably wouldn't have been a bad idea, but at the same time that would have required an extra junction point and a specialized cable to make that work. So it's not necessarily that this is going to not going to work or anything. It is just that that transistor is capable of sourcing a heck of a lot more current than this part of the application requires, because all of our current drive is going to be on the AC side through this. This is where we're getting our actual power to heat the bed. So this should not deliver any power at all, ever. Going back to the print, what we have is just the portion showing tapping off the power connections to the bed itself. So what you'll have is on this connection, you've actually got the line coming in from the power plug. So you'll have basically that connection coming from here. You'll have the neutral that needs to just be jumpered. And so that's where they're showing using one of those little jumpers that I had pointed out previously. That's over in my little stash here somewhere, and I'm not going to dig it up right now. You'll see it when I wire it up. So you jumper the neutral, and that's essentially it. So that gives you all of those AC connections. So at this point, I think I'm ready to go ahead and install these panels in place. It was a lot easier working on this without having it installed. So the new directions show essentially, you know, it gets you to this part of the assembly and shows you installing all the panels, and then going ahead and putting that panel on the board without any wires on it. You see the red notation here at the bottom is where you're adding those bolts to bolt this thing down. That means, of course, I'm going to have to raise this bed back up. But at this point now, I'm ready to make those connections, and I'll install this and reinstall the back panel, and then make the AC connections from the back panel to this. And from there, I'll be ready to start running some wires up to the top. Alright, so I'm back up on my soda can stand so that I'll be able to reach in underneath and drop put the screws in, as well as running all my cabling underneath. So pretty much looks like what you saw before, except it's now in place. You have to drop this front panel piece in as well at the same time, because again, these interlock, and you couldn't get these in without putting them in together. The back panel, since it pushes on, you know, it just pushes up to the thing. You don't have to worry about that. Before I put this on, I was going to go ahead and have this all bolted down, but I wanted to make one other note that I forgot to mention. If you want your power switch so that on is up and off is down, which is the way I have it mounted, what that implies is when you turn this around, you're going to either be reaching through the printer to turn it on here, or if you're reaching around this way, your power cord is going to be, actually get where you can see my hand. If you're reaching around this way, you're going to hit the power cord before you hit the power switch. So that's just something to be aware of. It's a decision to be made at this point in the game. You can always come back and reverse the screws, but you'll have to dig back into this. So I've decided I don't think it's going to be a big deal reaching through the printer to turn it on or reaching across the cord because my arms are long enough. But since this is such a big printer and you've got to reach around behind to flip that switch, it's a consideration. Alright, so give me a couple of minutes to get this all bolted down and we'll do a little more cabling. Alright, so one comment when you go to remount that back panel, you'll probably want to have your top plate handy and set it on there just to make sure it fits and that everything is essentially clearing your vertical posts here, because what I saw when I first put that back panel is that because you've got the power supply there weighting this down, it's basically just supported from the side. This whole panel on this side wants to lean in, and so it was actually pushing that back panel over to the right and making it want to basically screw in crooked. So in order to try to make sure everything's square, again, you want to double check your alignment along this back edge and make sure everything goes back in straight. Alright, so with this connected, we can start doing a little more wiring. One other comment after putting this on, you'll notice this back corner. Let's see if I can get it back in place here. Come on top. You can see it's trying to lean to one side. It doesn't actually want to go in on its own because I haven't bolted everything down. Anyway, that's good enough. So you can see that there's a big gap there and a smaller gap there. Again, intended obviously for your cables that are coming up. Now, you've already seen my treatment for this cable, and I'm going to be doing the same thing on the front side here. The problem is there's no place to go into the box until I get down here to this entry. So I'm basically going to bring that down, and I'm probably going to do that before I bolt all this stuff in place, so that I've got that cover. And then the bigger gap on the side will be where the those two RJ45 cables and the Bowden steppers and all that other stuff comes up in one of those tubes. Alright, 5 more 16mm M3s with the square nuts in here, and we now have this all bolted down. One comment, you have to put these on pretty much from the outside because on the inside you got circuit boards and power supplies blocking things, and that was a real bugger given that both of these are right behind the posts. So that was a poor choice. Even though it might be a symmetrical position, that's not a very good choice for where to put those. So in terms of future revisions, that would be one recommendation. But I managed to use my tweezers and get those in there, so that's what you get. You'll notice I've also put some more protection around that slot and routed the other stepper motor down the other column, and running it now through the opening there. And I'm going to go and do the rest of the wiring internally, or at least part of it. But I wanted to also show you this setup. Basically, you know, you want to try to minimize the coupling between the AC line and the thermocouple line. So I did a very fine twist on those. They're too stiff to do too much to. But basically I twisted them both independently just to kind of keep them together, and then wrapped them around each other. And now I have a piece of this material that I'm going to slip them through and clamp that at both ends, and that will then be my nicely protected cable running up and down. So we'll show you that when we come. Alright, so I now have the bed heater and thermistor cable completely coated in this black plastic tube, and solidly strain relieved here at the top using those double stick tie wrap pads. As it was, there was of course no strain relief, so anything that happened to that cable, you're pulling directly on the electrical connections that are going into the silicone rubber. So I'll let you guess about whether or not that would be warranted when that pulls loose. So now, originally, I had planned on just letting it hang off the end, although, you know, that's right in where the screw would be. But I was going to hang it off and come straight down here and go right into this hole. The problem is, when I look at the clearance, and I could probably drop the bed down and show you that. That's the bed all the way up. And so as we bring it down, you can see our clearance to the box would not have let that tube go through it. Now, this works nicely and goes through my nice double insulated spot. The problem is, with that amount of cable, I can't quite reach the AC connection I need to make on that unit. Now, I could probably flip it around and make that work, but the reality is I think I'm better off going ahead and bringing it in the back. That's going to get very crowded around that little opening I was showing earlier. But that looks like that's really the only way to get this in reliably. That's going to mean that it's going to hang off the top of this. Now, my other option is I've got all these little holes on the back. I may just actually fish it through one of those hexagonal holes, since there's not really a fan mounting there anyway, so they're never going to be used for a fan to begin with. And in terms of ventilation, it can easily pull it through the tube as anywhere else. The other thing I'll show you on the tube is I basically use black electrical tape at various places just to keep it closed, keep the wires from accidentally falling out somewhere along the line. You could use tie wraps, but then you'd typically crimp the cable, plus you'd risk the tie wrap snagging on things. So I'm avoiding that approach. So as a quick conceptual check, if I tried to use that opening, I'd be trying to squeeze that plus 2 Ethernet cables, 2 stepper cables, the hot end power supply cable, so we'd get pretty crowded there. Plus, I don't really like having this moving part rubbing against those other components if I don't have to have that. Going back and looking at this, I was checking to see, okay, maybe you're supposed to route it underneath there, but no, it's all the electrical comes out far too far to the end. You can certainly bring the hot or the temperature sensor out that way, it looks like, but everything's really set up to come out this end. It'd just be really nice if there was actually a hole there so that you could run that straight down and have a much closer shot to this. On the other hand, the one thing about looping underneath the table in general is that you risk getting caught up underneath this rail and reducing your overall height that you can go before you bottom out. So, with that, and given my options, I think my best option is going to be to go ahead and use one of those vent holes and turn that into my signal. One warning, you might be tempted to try to run different wires through each one of those holes. Especially when you're running high current AC, you never split the conductors. They've got to stay together. If I ran it one conductor through one hole, another conductor through another, now I've created a transformer essentially around that piece of aluminum, and I'm inducing currents in that aluminum that we don't want. So again, there's a reason why I keep talking about using these twisted wires. It's good from an interference standpoint, but it's also important from a safety standpoint, especially when you're dealing with high voltages. So just, again, things to be aware of when we talk about electronics and electrical. Now, looking at their wiring diagram, as you would expect, they do expect that you're going to run the power for the bed through this hole, but this all implies that you're just leaving those wires completely unsupported and flopping out here openly with basically 2 AC wires. Again, you've got these nice edges that, you know, they're not going to slice anything immediately, but, you know, give it a year of running back and forth, rubbing against that edge, and you're going to cut through that wire, or through the insulation. So, again, just not a good idea. Now, the one thing, here's what I'm doing back here at the moment, and I haven't completed this yet. The kit that I got from Home Depot comes actually with a piece of 3/8 inch hose and a piece of 1/2 inch hose. So I'm using the 1/2 inch hose as my additional layer of insulation, and it actually gives me something. I put some electrical tape around it, and I'll probably put some tie wraps on it to force it to stay there. But I can basically pull this other hose through it. I'm not going to actually adjust it because I kind of have it where I think I want it. Now, the one thing, so this gives me plenty of length for my AC connections. I still have the 2 temperature sensor leads that have to be coupled to a connector and then make it over here. I may now be a little short to use the approach that I was planning, where I'm going to take this connector off the fan. The other thing that I don't like doing in general, for the most part, this is pretty nicely designed where all of the AC is restricted to this side of the box, all of the DC to the left side, with the exception of the fact that everything else we're going to run has to run past it. So we're already kind of violating the keep the low voltage separate from the high voltage, because our stepper motor cables and everything else are going to run right past all this stuff to get out the back side. So I'd prefer not to do that, but this was not designed to support that unless we take all of that out the bottom along with the central stepper motor and bring it up the back, but I don't think the cables are going to be long enough if we tried to do that. So that's where we are at the moment. I'm going to continue working on this and may try to figure out a way to get better access to this side so that I can work it easier, but that's probably where this is going to stop for now. Okay, so in routing the cable for this stepper motor, you'll notice I've got it covered with some electrical tape to protect it against the sharp edges going through the box. Down underneath, we've got it with tie wraps and sticky tabs. An absolute must to keep it out of the belt. I don't know how they planned on you doing anything without getting stuff like that. Initially, I thought I was going to have to rip this all apart and rearrange things, because I was trying to use the 1/2 meter cable, and it wouldn't reach. It would get to right here, not to mention you were having to run it under the belt, but you would get to right here and you couldn't quite get to the connector. It suddenly struck me that because this board is offset, I definitely need the 1 meter cable to go to that stepper, but it turns out I could get by with using the 1/2 meter cable on this stepper coming down this column. So that freed up the 1 meter cable to run underneath, and so that's what I have now, and you'll notice I have just enough to get where I need to go. While I was there, like I say, initially I was thinking I was going to turn this around. From a design standpoint, it would have made sense to actually put the stepper motor on this side and have a shorter run, but that's somewhat immaterial at this point. It would have avoided that interference potential between the cables. And there is actually a feed through, you'll notice, right here. So that's where I was trying to come up through, because there was no way it would reach from over here with that shorter cable. While I was in there, you'll notice now that I've got a different head screw here. I went ahead and I put in the 40 millimeter screw, so that now, I'll try to get this zoomed in there. Now you can see that the two belts run even. Of course, you can also tell the difference between stainless steel and zinc plated. I'd much rather have stainless parts for everything, but unfortunately, having to deal with a local big box home improvement store, you get what you get. So that's our setup here now. Now for our x-axis, that's the dual motor drive, and we've got this little jumper board, which it was kind of interesting just looking at the setup. Basically what they've got are the two connectors are set up face to face. What that does is that makes it so that one motor will turn clockwise, the other will turn counterclockwise with the same stepper signals. So again, these are being run in parallel simply because there's not an extra drive. If you're going to have the Bowden, you couldn't run them both anyway. The one thing about this was in this little bag with these two jumpers. This white one is the one that they're showing to use for the neutral connection. Presumably, I guess, actually now that I look at this one being the double, this must be how they intend to jumper the thermocouple wire, right? So that would be that. Now this is all in here with this little piece of double stick tape, which is potentially okay for those two blocks, but I don't want to use that to attach this circuit board because there's the potential that those pins would actually puncture the double stick tape and touch the aluminum. So I want to avoid that, so I'm going to come up with a different way to mount this. Again, unfortunately, there's the two screw holes, but there doesn't appear to be any place to actually mount that in here, and certainly no standoffs to do it with either. And so here's my solution for holding that board in place. It's not perfect, but it certainly protects it. It's basically another one of those tie wrap stick-ons with a tie wrap through the board. It can rock a little bit. Can't quite pull the tie wrap tight enough. I might try a smaller tie wrap and see if I can get a little better cinch on it. But beyond that, I mean, it can't touch the board even if I try. So I mean, it can't touch. Sorry, can't touch the bottom at all. So I'm not too concerned about that, and for the most part, that's relatively clean and not too much in the way. I could have stuck it somewhere else, but that's about as much cable as I have to work with in both directions, so it puts it about where it needs to be. All right, so unfortunately, like I say, I still need the 2 cables for this. One other comment I was going to make, I mentioned looking at Amazon. The one difference I was seeing was that most of the cables they're selling, these are actually ribbon cables. And then they're just split at the connector end to make the connection. So they're already bundled relatively tightly as opposed to these loose wires that we have on all of these connectors. So again, just, no real additional cost for that. Frankly, some of those were cheaper than others. So, the reality is this could be better just by, choosing slightly better cables that don't necessarily cost anymore. Another day gone by and still no response from Folger Tech regarding the missing cables for the extruder. And, given that Amazon had one set of 2-meter cables in stock, I went ahead and placed the order. Unfortunately, it won't be here till Monday for some reason. So that means I don't get to play with this completely over the weekend, although I can hopefully at least get it set up and started testing the axes. I bought this from Folger Tech because I wanted a U.S. company that would hopefully be able to provide support. And while I understand that it's been the holiday season, the reality is this was not ready to be shipped, certainly was not documented well, and did not have a good enough packing list to make sure they got all the parts. So, if you're not ready, don't ship it. If you're going to ship it, make sure you're there to support it. Anyway, off the rant and on to showing where we're at. So as we showed previously, we've got the 3 motor cables. So we got the Y-axis, the Z-axis, the Y-axis that goes up to through the Ethernet cable basically, and then the X-axis that has this splitter, and we feed 1/2 of it up one column using a 1-meter cable, 1/2 meter cable going to the other column, and then these are 2 of the short jumpers. The 3rd short one goes up on the gantry itself. Now, back to some of our high voltage wiring. So that's what we really had left to finish. And as I was showing previously, I was bringing the cable for the bed through the back here, and you can see now that I've added a tie wrap on both sides to keep that little insert from slipping either way. And this, even though I put most of this together before assembling it, frankly, and especially from my access angle here, this is a very tight area, and as you start trying to get all of these cables in place, you very quickly run out of room. But if you look down at the power supply now, you can see we have line, neutral, and ground going to those first 3 inputs on the power supply. We have the other short line jumper coming off and going to the first input of the solid state relay. The second connection goes to our heater on the bed. Then we have this neutral coming back, and that needs to tie to there. Now, what they provide, if I didn't just lose it again, is this little jumper, and they actually show this in their updated documentation. And it's basically a double, it's basically a mounting block. If you look, it had some sort of a ring here designed either to be screwed onto something that they just broke off, so I don't know what this came from. But this is the bigger problem. It's got an opening there for the one wire. The other end of the particular part they sent me is capped. So I'm going to have to break that open. I don't know if it's a defective part or if this particular part was just designed to be a termination, not a jumper. So I'll figure that out. Part of me is tempted to just forego this and solder these things together and heat shrink them and do it that way. But for the sake of finishing this, I'll try to see if I can get that working. Now, on to the temperature sensor, the thermistor. You can see the red line down there. I've actually routed that underneath the power supply so that it's out of the way. And you'll notice that I've got some nice heat shrink here, and if you can see the rest of the line, I've actually got little pieces of heat shrink to keep those two wires together. Now, I mentioned about planning to use the end off of the fan connection that has to go right there, and that's what I cut off. But unfortunately, given the direction that this was routed, that just wasn't long enough to get me there. So that didn't work. This is apparently from whatever kit they're drawing from. This is the thermistor lead that I believe they intend for you to chop off and use. The reality was, don't know that I'll need a thermistor, but you never know. And I kind of really hated to just destroy that cable that could be used for something else later. So instead, I tracked down a fan that I had laying around that was shot and took the entire cable off of that. So now I can toss this. But that gave me a plenty long cable to reach, and it's the perfect length now. And so I soldered the two leads together, heat shrunk each one, and then a heat shrink sleeve over top of it to bundle it all up. And I have a very nice, clean thermistor lead going back. And when I bundle all this stuff up and make it nice and neat, I'll clean that up with it as well. So at this point, with the exception of the two cables we don't have and plugging in the two Ethernet cables that need to be routed up, I've already attached this long black lead, which is currently just a loop. I haven't even cut the other end, so this is a don't power it up or you'll cook this lead. But this is the cable for the hot end. So this is the high current lead for the hot end. And that will route up with everything else up to the top. And so as soon as I solve this AC problem, that's my next step, is to route all of that. And essentially then, after just double checking everything, we will be ready to see about firing this up and programming some firmware. Probably, actually I don't think I'll bother putting the display on the front right now until we see what happens just from a PC interface. Alright, so at this point I've kind of cinched everything up and installed some of the last cables, which I'll talk about in a moment. This is what I ended up doing for that neutral connection. It turns out that that block that's in there is designed to pop out, so that wasn't too hard to pop that piece out and open up both ends. But when I went to see about taping this thing on using the little piece of double stick tape, if I mounted it to this metal panel, that electrical connection was far too close to that. Certainly would not meet any sort of code. So I didn't like that. I debated putting it on here. The only issue was this will potentially get warm. And it just made the cable routing. I had this big white loop out here. So ended up doing like I've done a couple of other places, just used one of my tie wrap mounts and stuck that to that with one of the small tie wraps, and that way if I need to I can still get in there with a screwdriver and loosen those wires. And that takes care of that. Like I say, I'm still not overly thrilled with it. I would almost just as well connect those permanently, but this does allow it to be adjustable. Now, again, I've got this big wad of AC power lines here, and, you know, as I mentioned about safety, I can come in here and play around with my electrical lines. That's not very good. So, again, it's just too close, too easy to stick a screwdriver or something in there, kids playing around, etc. So, from a safety standpoint, that's just not a very good solution. I also really dislike running DC lines by AC. Now, I've got the stepper motor running underneath, and as well as the sensor line here, the temperature sensor. But for the power, I ended up, since I already had DC lines coming off the power supply coming this way, the big red and black, that's where I've run this. Now, I've got these two cables that I think at this point I'm really debating. I may run them down and take some of that black tubing and cover this all the way back to here so that it's essentially all isolated, and so that would imply running these underneath. Or I may run them up here. We'll see as I finish this off which way I decide to go. These cables are all nearly thin enough that I probably could put them in this side rail, and especially if I got one of the standard caps that snaps in over this, I might actually be able to leave those in there, but I still, again, have to run the two stepper drive lines up. So I can't do everything inside the rail, even though this stuff might fit. Of course, I cinched all that down, just kind of cleaned it up a little. The final thing was putting in the USB cable to the front, and again, we've got a bit of a problem in the choice of what they provided. You notice that this thing, the bend radius that you're having to put on that so that it will clear the cover, that is just really tighter than that cable should be bent. But that's essentially what we're going to have to do. I may actually just tie wrap that down like that to keep it clean and keep that from going any higher. But then this screws in with two M310s. It is actually threaded in the connector, which that was a kind of a nice touch. And then finally, this is where the USB cable is. So presumably, if you don't buy one of their two display and interface options, if you're just going to run this off the PC, this is apparently what the front end of your printer would look like, whether or not you put the black loop on there. This is basically what you would have, is this big open hole here, because I don't see anything else to cover it other than one of the two panels. So that's kind of where you're at if you haven't bought any of the extras. So, you know, I mean, that's kind of where I am at right now, because I don't have the extruder. I don't have any directions on how that box of parts for the display is supposed to hook up. But this pretty much completes all of the internal wiring. So it's really just a matter of jumpering all of this stuff up to where it goes and finishing the hookup on the carrier that I haven't bothered to do yet, just because I hadn't decided exactly how to deal with the wires and keeping them up off the print bed. So that will be the next step. Alright, so just playing around with lead links here and trying to get an idea of how things will run. Basically, so you've got your two Bowden tubes, which are, I cut a little long, but there's really no good support structure for this, so I don't know for sure how I'm going to keep this from hanging down onto the print bed when the print bed's low. If anything, the bowden outputs really should probably be vertical so that your tubing would want to make a vertical loop and then follow the print head around. There's, potentially I could rearrange it. It's a bit more of a challenge than for where the spools go. And frankly, the more I think of this, I'm kind of wondering why the heck this whole assembly's not on the front, especially depending on where you're putting it, because frankly, for this size, granted it's up off the ground, but it might actually be nicer to have all of your spools up where you can get to them at the front of the equipment. And I don't see any reason that you couldn't make that choice one way or the other. Now, going from there, here's our next problem. So the Ethernet cable, which I did not mean to route around there when I plugged that in, that's not good. Let's get that unplugged. So this cable that carries most of the signals up, that's fine. That's plenty long. It can route up the side and around, so that's all fine. This is the power cord that needs to follow the exact same path. And remember, we looped it in half. This was that wad of wire that we had. That's got to go there. And unfortunately, it just isn't long enough. So, since I need a good, flexible, high current wire, I'm going to have to try to decide what this is and get some more of that. Now, potentially, if I were to run it up the front and have it come off the front of the printer, I would get back a little bit of this distance. Not much, because it starts just a little bit to one side of the halfway point before it comes out. And the reality is, this is where all of this stuff's supposed to feed. That's where we have that hole. Okay, so I decided to go ahead and work on wiring up at least the components that go to this little jumper board. And so I'm starting with the bed sensor. I don't want to try to bend that cable to go underneath like everything else will. So instead I'm routing that across and down, and then hopefully now this is just long enough to get to the connection it needs to. Again, with enough loop so that if I need to move this up or down, I can do so without too much problem. The other thing you'll notice is I went ahead and I tinned, if it'll focus on them, I tinned the ends of each of these leads with my soldering iron, because these are very thin wires, and by the time they go into that clip, I wasn't confident of them holding up for a long time otherwise. So there's, quite a bit of lead that you're taking off of this in terms of what it comes with. And going back to the color code, this is actually matching the international code that I talked about previously for the AC. It's got brown as the line, the plus voltage, blue as the neutral or zero, and then it's actually using black as the signal lead. So that's kind of interesting. I did take my meter and confirm the connections here. So the plus does go to what I have connected to the plus 24 volts. The minus goes to the common or ground connection. The signal goes to the signal connector on here that doesn't actually, whoops, sorry, not sure where I'm pointing. So the signal goes to the signal connector on here, but that signal connector actually needs to be signaling this. So the blue line, I believe there, comes over to be the Z-axis limit switch. Now my hope is, the reason that I don't see continuity there is you see this little circuit there that looks like it's coming off of that. So I believe what you've got is it's an open collector signal, and I think this is converting it to the desired logic level that's needed for that. So until there's power, we won't actually see the actuation that occurs. But given where you see the leads going, that makes sense as to being that's what that component is. So we'll get this plugged in, we'll get the fan in, and then we'll see about trimming the hot end and thermistor leads and finish this off. Alright, so rather than cutting the heater and temperature sensor lead short, I decided to just route them up across the circuit board and around in a nice long loop. I can always cut them shorter later if I want to, but this should handle that. The one thing I will say, you know, these Wago connectors, they're cool, you know, just a push in and clip type of thing, but they're only cool for applications that they're really good for, and frankly, this is not a case where these are very useful. It was a real pain to get the level sensor into that connector. I'd much rather just have a Phoenix type connector with a screw and stick the lead in, tighten the screw. It makes life a lot easier. Part of the problem was, of course, that by the time you go to push the lead in far enough, you start moving the carriage. So I actually had to move the carriage all the way to the far end, which, by the way, you should really not move a stepper under load. So if you're going to do that, you're better to unplug the stepper from the drive, because it does generate a decent amount of back EMF, and while that should be able to handle it, the potential of blowing circuitry is not something you want to deal with. At any rate, so I have that in, and as I went to screw in this into the Phoenix connector, I'm going, why is that so loose? Well, coming back to the back side, it would appear that it got stuck in but never actually soldered into place. So now I get to pull that board off and check the solder joints on all the connections and actually make sure that we've got solid soldered in components here. So again, mechanically, I'm relatively pleased with the design of this printer. Electrically, it's becoming more and more disappointing. So, coming back to this part, you may recall me discussing the problems with this in the assembly video. And so yesterday, I had the Ethernet cable installed in here, and needed to remove that to try work on rerouting the cable. And as I went to pull it out, this entire thing fell out. And the reason, as you can see, are that both of these T-nuts, because those screws are not long enough, after I'd reset the belt and attempted to tighten this down, neither of them, they both aligned into the slot, and neither of them actually caught anything. So this thing's just been sitting there loose the entire time. And the only thing that was holding it in place was the belt tension. So I get to loosen this up and try to address that, but I may end up either going and finding some new screws or taking two longer screws and chopping them off so that they'll fit, because I'm not sure where I'm going to get 12 to 14 millimeter screws locally. But I wanted to point that out again. Plus, after the fiasco of finding solder joints that they failed to solder properly, I need to check every circuit board anyway. So this one, not the most beautiful solder job, but does at least appear to have all of the connections soldered. And I will be checking the main board over here as well, to make sure that that one is done. You can already see, I mean, I was noticing this from the beginning and just kind of ignoring it, but that socket was soldered in completely crooked. So whoever's doing their circuit board assembly is not doing a very good job. And like I say, this kind of goes hat in hand, that the quality control, quality assurance that I'm seeing here, both mechanically and electrically now, are problematic. Okay, on to the next problem. You'll recall that I was discussing basically this wire right here that goes to the fan. Okay, and you see how I have it routed to the fan control. And if I dig up the documentation, if I compare the original wiring diagram, actually you'll see that the fan doesn't have a connection at all, versus here it's shown to run off the 12 volts. And as I was working on this, I'm going, no, wait a minute, that fan is supposed to be being controlled by the fan control from the main board. Well, that's not actually correct. The reason it's not correct, and I wasn't thinking about this, that's not the proper fan. That fan is just cooling the intake for the hot end. So it's just keeping the filament from melting as it comes down into the hot end. What's missing on this, and I did not realize, there is no extrusion cooler. So when it comes time for this printer to try to do a bridge or a large overhang or something where you really need cooling on the surface of what you're doing, these prints are going to fail. So that struck me as an amazing oversight. You know, again, not something I would have expected. You know, again, coming over to my Robo here, you can see it's not a beautiful design, but it's got this little fan that sits there and blows on everything. And then I believe somewhere on the other side there is also a fan that's cooling the fins, but I'm not positive. So, yes, this fan, generally I'm not overly thrilled with the idea of it being on all the time. It'd be nice if it was controlled to be on only when you have the print head running, but I don't think there's an extra control line to do that. But the reality is I want a cooler that's going to cool the extrusion when it comes out. Since I've got only this one fan connection, what my plan is, I'm going to take these two leads that currently are labeled fan, and I'm going to move them and actually probably go ahead and just solder the leads together for the plus and minus here, and insert them in here because I've already got power supply going to the sensor here. So if I just use that power, I can have that fan on, and I still have the run for this fan control that now, over the next day or so, I've already ordered off of Amazon some 40 millimeter, which I think will work well there, but some small fans, and I'm just going to build a 3D print a housing and hang it off of either these screws or something in here. I was debating actually hanging it off the cool side, but I figured that's too close and would end up melting if I got it here, or sagging at a minimum. So I'm actually going to mount the fan back here somewhere, but have, you know, a nozzle essentially that points toward the filament. So now I get to put all this stuff into a 3D model and design something else that they failed to include with the kit. Next, we come to the reason why I had disconnected the cables. You know, I'm working on routing everything, and so I'm looking at how the cables can come up the column. I'm realizing that they have this one small feed through here that would appear to be suitable, although it'd be nicer if it was closer to the corners, but appears to be suitable for bringing the cables up. Unfortunately, I'll do it from the top so that you can see it. these Ethernet connectors on the end, these RJ45s, are not going through those holes. So the idea of nice clean cable routing, as I was hoping, is pretty much out the window. And frankly, if I go and I look at those tiny pictures on their website, what I see is a big wad of cable hanging out the back. Now, the one thing that I could potentially do, the problem is it would require loosening this rail to be able to pull it back, and also having to get past this plate. But there is enough room within this rail to actually run the sets of wires that I need to run for everything except for when I get the two steppers up here. So I could do a really nice clean job of that if I wanted to disassemble half the printer. And I'm not sure I'm quite up for that task at the moment. One other comment, looking at those Folger Tech drawings of this and where they have everything routed down, it does appear that they have spiral wrap over everything. So obviously they used it in their prototype design that they took all the pictures of, but they didn't bother to provide that with the kit. The other comment, the one thing that struck me is rather interesting looking at their website, I realized something notably different between the Folger Tech pictures of their printers and virtually every other 3D printer manufacturer out there, in that they don't actually show that this thing has ever printed anything. They don't show printing things on their printers. So it's, you know, may just be they want to just show off their printer, but it seems to me that it kind of does point to how this is more of, well, we designed it, and here it is, but whether or not it works is a different story. Alright, so before I attempt to reattach this, I decided to go ahead and attach the jumper cable. Again, since none of this stuff is custom, these cables are relatively long, so in addition to twisting them, I actually knotted through a couple of times, as opposed to trying to do a tie wrap and a bunch of stuff. This was just an easy way to do it. I'll have to check and make sure that that doesn't bump into anything on the back once this is installed, and so we will see. Alright, so I did finally manage to get this thing remounted, but only after lots of finagling. Basically I had these screws hanging on, or the nuts hanging on, by less than half a thread. I managed to get the front one to turn in. I actually had to unscrew it and then rescrew it and got it to turn in and lock. At least it feels like it's locked. The back one, the nut fell off and I couldn't recapture it, and it ended up sliding down inside the tube. So I had to get something sticky to pull it out. Being stainless, these things aren't necessarily magnetic. And once I got it out, then I put it in the right way, just already twisted in, and still had a lot of difficulty getting that screw to catch it, partly because this whole assembly wants to twist, and so it's twisting actually into the screw is actually binding up against one side of the rail on the back side. And so you have to actually take that load off to even get it centered on the nut and be able to catch the nut. Even then, it's only about, maybe a turn into that nut, if that. So, still need longer screws. So I've designed and printed on my Robo 3D a duct for cooling the freshly printed plastic as it comes off the extruder. And so what you can see is basically this will mount like that and scan across, so you'll have a little bit of air flowing towards the extruder. Most of it's pointing straight down. Got a little bit of plastic threads there. But this is designed for a no support print with over probably 50 degrees or more of slope to it, and generally prints quite nice, but you have to have a cooling fan to be sure that you can do that. So where this goes is up here. I've actually already pulled the screws, and so this will mount right in between, if I can, get that into place. So this will mount right there. I've got to put the 2 screws on, and it will basically be just above the tip. And so I'll slip those screws in there and show you the finished assembly. Here we now have the part installed. You see how it just sits on the screws that go through and hold the bottom of this assembly together. And it's adjusted to just clear the screws that hold the hot end on. Presumably you'd be able to unscrew those while it's on there, but I'm not positive. So tomorrow, when Amazon delivers my set of 24 volt 40 millimeter fans, I'll be able to put one on here and confirm that this actually works. So you see, like I say, it's just above the tip, and that should do a very nice job. So, as I mentioned before, from an electrical standpoint, we're going to take the 2 wires that are going to the cooling fan for the top and hardwire those in here so that they're that one's permanently on when the power supply's on, and then the new fan will plug in where that existing fan is right now. And of course I still have to solder that Bad Phoenix connector there. Alright, so the first part of my order from Amazon arrived today. Unfortunately, the stepper motor cables won't arrive till Monday. But you can see now I have my fan for my cooler. And as I mentioned, that fan now is going into the line that's going to be controlled from the controller, and the other fan that's on the front is now soldered into those 2 leads so that the power and ground are coming off the 24 volt supply that's the same supply feeding the sensor. And that way that fan will be on all the time and I don't have to run an extra wire to run it. I also got an actual kit of silicone wire, 18 gauge, to match essentially what they had provided, but that wasn't long enough. So now I can use their strand and this new roll and get enough to go around. Plus, now I can pretty easily twist these 2 up and keep them together. And I also, if we can look in there, you can actually see the mess of rosin because I haven't cleaned this up, but you can see that I've soldered that connector in that was loose. So now we are essentially ready to go. I'm going to start routing these cables back. And what I'm going to do is start bundling here. Rather than routing from the bottom, I'm going to route from the top. And as I bundle this together, then I'll route it down through and figure out the links and take up the excess down below. So, that's where we're at now. Alright, so as I believe I mentioned, I'm starting from the carrier and working my way back. So I went ahead and I cut the 2 bowden lines short, basically just figuring out what would get me closest to the end. I'll show you the cut-off pieces to give you an idea of how much I cut. And I'm running that, the heater power, and the RJ45 through it, and basically a whole bunch of tie wraps here. You know, it's ugly, but there's really no good attachment points on this thing. So that's the best way, and that gets the cable going straight up. And So it seems to actually work pretty well. So if I run this back and forth, you can see what we get there. I run it down to this end and bring it back. So you see we're pretty good there. And running it over here, again, pretty clean. And finally back to the back. So I'm pretty happy with that. I think that'll work well enough. And you'll notice that this cable goes back through, and so right now what we have coming out of it are, like I say, the heater lines and the RJ45. This is really about as far as I can take this line at the moment, because I need to actually put those two steppers in there as well. So when I get the stepper cables Monday, I'll be able to finish that whole cable, and I'll attach it to the back of the rail with P-clips and bring it down off the back side. Unfortunately, there's no good handling here unless I were to bring it inside, but then I get blocked here. There's no place to go. So I will probably just use a hidden sticky tab on the back of this just to make the corner. Alright, so that's where we're at this point. But our carrier is essentially done. I promised I would show how much I had cut off of the bowden line, so that's just under a foot. So, you know, close to 2 feet out of the total length they gave me. That probably doesn't help much. You'd rather know what the length is coming from the bowden, but that would have been a pain to measure. I also cut off just a little bit off of my back line here, because that was actually, by the time it hit the pulley, that was limiting my range of motion for the left edge of the bed. So I went ahead and trimmed that as well. So I thought I would find out how the horizontal cable would fit if I just left it out and only relying on that connector for all strain relief, etc. This doesn't have to move back and forward on the bed, but it has to move left to right. And so basically, here's the situation. Let me pull back here. And you can see that that randomly wraps. So if we were to leave that like that, that's going to get caught up in the belt, or it's going to drift down to the print surface, or it's going to do something that we don't want it to do. So, unfortunately, there's no good tie points here, so we're back to figuring something out, but I'm going to take a small piece of this and go ahead and route that through it and bring it up and over so that it hopefully will behave itself a little better. And we'll see how that turns out. Okay, so here's what I came up with for dealing with that cable. Basically, I've got it facing towards the back using a sticky on top of the motor. I don't want to put too much of that. Certainly don't want to put a lot of those on there, because that is basically insulation, and this motor is likely to get pretty warm. But hopefully that will still hold. I actually have, you might be able to see here, this little tie wrap that's going this way that's just a stub that I was then able to capture with this tie wrap, and that helps force this to stay around. Otherwise, I was running into interference where these two cables are hitting each other. But by having it go out the back, and you'll notice I did basically the same thing here, where I've tie wrapped this to the bowden line just to try to keep it facing backwards, because otherwise it still wanted to hang down. And it was probably okay, but depending on which side I was on, I'd end up with this loop that would start getting down. I actually, depending on which way I had it come down as far as this one time. And I don't want it hitting the fan either. So, oops, show that part of it. So as I come across, these things flip underneath each other. And so that does the type of behavior that I want to see. And then from there, up under here, you can probably see the gray cable come out, goes into the other main run, and comes across. Now, of course, this will be strapped to the back once I get the last conductors in, but for now, this was an easy way to route it. Comes down, we'll go into the case. Now, this little flag right here is the halfway point on the hot end wire that they gave me. So that's where I would have been if I had cut that in half and routed. So, you know, like I said, I'm still using the additional roll I bought plus their wire and twisting those in. And the goal here is that basically we'll have this bringing everything, all the low voltage past the AC, and I'll tie it back into where I had this stuff originally. And that way that will be quite safe. And I've got, you know, a foot or two now of the gray and black cables that I have to basically roll up and put somewhere. But that gives you an idea. So at this point, I am just about ready to plug this in and, you know, hook those last connections up, plug it in, and do some testing. Before I test this, I'm actually going to pull the 24 volt supply off of this board and just power up that 24 volt supply, make sure that it works. If you'll recall, there was something rattling around inside it. The last thing I want is for this to damage all the low voltage electronics due to some problem with the power supply they provided me. There was no firmware for this thing, and so I had sent another email to Folger Tech saying, do I need to set up my own as well? They did respond back to that, saying they posted a test version that would be working on a new version, who knows when, but they did post something online after I said that. They also posted a whole bunch of links for the board that's going to be on the front, the display and everything. And it's basically links to a Chinese website with download limits. So you're downloading from some unknown Chinese sharing site to get the firmware to run the little Pi board and whatever that does. So use at your own risk. That's a Wi-Fi enabled board. You're bringing that inside your firewall. You know, I'd much rather have something that the company I'm buying from was selling and would vet and, you know, at least give me some assurance that it was clean. But you get what you pay for, I guess, and this was a cheap printer, and it's turning out it's a cheap result. So I mentioned that Folger Tech did at least respond about the firmware, but they have still not acknowledged, much less sent, any of the missing parts that I've had to order. And so, you know, I guess you're on your own as far as any sort of support. The end result, so basically I spent just about what I saved for pre-ordering this at Thanksgiving and getting the discount that they had for their Black Friday sale. I've spent all of that buying over-the-counter parts to finish this off. So, hasn't really been a bargain for me either. Now, one other thing I just noticed as I'm standing here talking is the way these wires, when I hit the limit, those wires are all interfering here. So I'm not really happy with that, because that's essentially a wear point. Every single time I home, those wires are going to hit. I guess the best solution I have is going to be to put a spacer here if I want to try to keep that off. I might dress those some other way, but other than pulling them up so that they are coming out of those connectors at a very sharp angle and go across the top. That's about the only other way to deal with that. So again, just one more thing in terms of the poor coordination between the electrical and mechanical aspects of this printer. So by the way, I tried calling Folger Tech because I wasn't getting any response by email, and all you get is a recording that says to email them. So no one's there answering the phone. And so, again, take that for what it's worth. That's the company that you're apparently dealing with if you decide to get one of these. So with that, I'm going to call this video done. My programming and testing video, when I get the remaining cables, you'll get to see the final assembly in the testing video that will follow this. So thanks for your interest, and hope this helps somebody either in making their decision about whether or not to buy this printer, as well as if you've bought it, figuring out how to get it assembled and what parts you need that weren't supplied.